an international journal published by SAGE for the last 25, 26 years. It's a journal where medieval as well as history, they are both very expansive terms. Medieval is not restricted to any particular dates. Medieval certainly does include early modern, but I think it's we leave it to each author to decide what medieval or early modern means in his or her region or context. And history is all inclusive here. Nothing is excluded from the domain of history in MHJ. So you are all welcome to consider publishing in MHJ on any theme of medieval and early modern history in any region and any aspect. MHJ also holds every year an annual lecture. It has been holding for the last 14 years, so this is the 15th year regularly. Every year we invite the world's foremost speakers, foremost historians to deliver a lecture on his or her theme, a theme of his or her choice, current choice usually. We have had lectures in this series on Europe, China, India, the Middle East, Latin America, and this time we are lucky to have a lecture on Africa. We are lucky because Professor Amanda Power was able to persuade Professor Innocent Pikirayi, who is professor at the University of Pretoria in South Africa, to give us a lecture, to give us this year's annual lecture, and he has kindly agreed. So you are welcome here. And Professor Amanda Power is the chairperson of this lecture. So I welcome her. She is one of the editors, so she doesn't need to be spoken very extensively about. She is a professor at Oxford University. So Amanda, please take it over from here.
Thank you very much. It's good to see everyone here. And I'm really delighted to welcome Professor Innocent Pikirayi, who I've only met on Zoom before, but here we are again. So I'm just going to introduce him briefly before we have the paper. So Professor Pikirayi is at the Department of Anthropology, Archaeology and Development Studies at the University of Pretoria in South Africa. He works on states, societies and environments in Southern Africa. And I discovered he's among the first Zimbabweans to train in archaeology after independence. And his research has focused on the rise, development and decline of Zimbabwe culture. So his 2001 monograph, The Zimbabwe Culture, Origins and Decline of Southern Zimbabwean States, was an important contribution to long-running efforts to understand the pre-colonial history of the state from the first herdsmen and farmers and their early connections with the Indian Ocean trading networks to political centralization from the 10th to 13th centuries, the struggles during the Little Ice Age and the subsequent histories until the era of European colonialism. Some of his works focused on crucial questions around building an indigenous and public understanding of the region's past, together with how this work should be resourced financially and how local communities might engage with it. And I've found this really interesting to follow myself. So I'd recommend particularly his 2015 article, The Future of Archaeology in Africa, that was published in Antiquity. And finally, he's also written on the contemporary value of understanding the deeper past of landscape, habitation, and urban settlements on the African continent. A co-authored article from last year in the journal Anthropocene looks at the longer history of water management in the region and the close involvement of the community to suggest a model for making more resilient futures in the region. So with all that exciting background, and I think we're going to hear a little bit more about some of that work in today's lecture, I'm delighted to welcome Professor Pikirayi to give this year's 15th annual Medieval History Journal lecture on granite landforms and water storage at Great Zimbabwe. So I hand over now.
Greetings from Southern Africa, and thank you very much for the privilege you have given me to deliver this annual lecture, the 15th in the series. Allow me to acknowledge Professors Muchia, Professors Nath, Professors Tuta, Professors Manuel, and Mrs. Jane Mampani for discussions leading to the scheduling of this lecture and the preparations that went into it. I also want to thank Professor Fernandez Scotts for the invitation to the University of Edinburgh next year to deliver the Monroe lecture. Professor Amanda Power, it is good to see you again, and thank you for sharing this lecture session. My lecture focuses on the ancient city of Great Zimbabwe, looking at its water resources and specifically from the geological context in which it is located. So allow me to share this screen so that you'll be able to see my presentation. Now, this research is a collaborative project involving researchers from institutions in Sweden, in Denmark, in the United Kingdom, and Zimbabwe. Great Zimbabwe has been referred to by many as a medieval city because it existed during the Middle Ages, starting from the 11th century and developing to its peak during the 15th century. This is when structures such as the great enclosure that you see in the left slide were completed, and then the settlement also started expanding beyond that. Great Zimbabwe continued for several centuries and probably came to an end during the 17th or 18th centuries. Now, presented in this slide are some of the kingdoms and empires of Africa and the Near East from the last 5,000 years or so. Great Zimbabwe presided over a kingdom that was part of an empire that occupied the entire Zimbabwe plateau and adjacent regions of Southern Africa. Until the 1980s, most of the research on Great Zimbabwe focused on who built the settlement and when. This was often dominated by highly politicized statements about the authorship of the site and the monumental complexes, and which unfortunately removed agency from the indigenous Karanga people who built it. On this slide are some of the artifacts that attest to Great Zimbabwe's connections with the world of the Eastern Mediterranean, the Persian Gulf, the Far East, the Indian Ocean zone, including the Indian subcontinent. It is the research on the development of ancient complex societies in sub-Saharan Africa that we started during the past decade, which set the tone for this lecture. In 2016, we published an article in the journal Wires Quarter where we demonstrated that the depressions that we still find within the ancient city of Great Zimbabwe today, sometimes referred to as the Dhaka pits or clay pits, were also used as water storage reservoirs. Now, this particular slide, or these two sets of slides rather, give you an idea of the depressions I'm referring to, where the ancients initially sourced their clay for construction purposes before reusing the same depressions for water storage purposes. Now, the full details on the nature of these depressions are highlighted in a paper that we published in December 2022 in the journal Anthropocene, a paper which is available open access. Now, in this lecture, I examine how water was sourced and channeled to these depressions. I also engage with ongoing hydrogeological studies on crystalline rock formations to understand how Great Zimbabwe functioned as a site and as an urban complex. And I try to highlight the importance of granite in Great Zimbabwe's location, which is broadly the landscape that you find at Great Zimbabwe. Granite, as you can see from these slides, is the dominant physical landscape of Great Zimbabwe. And it is important in so many ways. Crucially, it is building material, and also it is a water resource. The second point about water is most telling about Great Zimbabwe, particularly in terms of how water from the granite context emerged and was used and managed by the ancients. Now, the catchment of Great Zimbabwe shows that it had a localized radial drainage pattern. Practically, all its water runs off in all directions from the core of the settlement, which I'm showing you here. This is the core where you see the hill complex, the great enclosure, and other valley enclosures. And what you can see are streams draining north, streams draining south, southeast, streams draining west and then south, and other streams further away and rivers draining east and south again. Now, this points out immediately that one of the challenges residents of Great Zimbabwe had was immediate water runoff, which they had to manage, because immediate water runoff is a crisis in itself. You need some of this water back. So they had to manage the water that they were left with. The big question, though, is how did they manage this, and where were they getting their water from? To answer these questions, we employed several research methods within the context of geoarchaeological research, and I'll explain this in some detail in the next few slides. We conducted landscape surveys, focusing primarily on mapping the hydrological context and water resources of Great Zimbabwe. And this involved examining a region some 5-kilometer radius of Great Zimbabwe, documenting water bodies, particularly springs and streams. Then the local resident communities proved critical in providing the necessary hydrological information or characteristics of the area and other pertinent environmental knowledge, which, as you can see, is dominated by granite hills and dolerite soils. We also conducted geoarchaeological surveys to understand human impact on the landscape. Through soil profile sampling and analysis, it is possible to detect anthropogenic modifications of the Great Zimbabwe landscape. We also used this opportunity to understand a characterization of the granite formations around Great Zimbabwe. We also conducted archaeological excavations on selected monuments. And what you see here are the excavations that we conducted at a site called Chenga, which is some 3 kilometers east of the main architectural complexes at Great Zimbabwe. And this is one of the several sites that are classified as peripheral to Great Zimbabwe, but in fact served as an integral part of the core architectural complexes. And in the process, we also collected from the site numerous samples for geoarchaeological analysis. Another approach that we used was light detection and ranging, which is LiDAR for short, which scans were carried out to map Great Zimbabwe. Focus was on the less visible aspects adjacent to and beyond the built environment. And although the landscape around Great Zimbabwe is not a tree-heavy canopy like what you see in Mesoamerica, in which LiDAR could save archaeologists, we used it to carry out and try and understand locations with a difficult access. For example, locations that prove to be too high in terms of access, too deep, or even too steep, or locations which prove to be blocked in terms of access. All these to understand the layout of some of the features of Great Zimbabwe that lay beneath the surface. Now, with all this integrated approach to understanding Great Zimbabwe, we generated the following results. And from the landscape survey, for a start, we highlight details of toponyms and hydronyms, which show the importance of water, both during the past and in the present. And then the local traditions, as well as local narratives collected from the local communities, indicate some water sources such as springs and pools being owned by specific clans. And as such, ritual and ceremony were critical in regulating such places, and by extension, they were critical in regulating water. We can also say they were important tools or avenues in terms of water management. There are also local understandings around granite and water flow, as well as water storage, and how granite is critical catchment for seasonal as well as occasional, rains. In this particular context, local names such as Maware indicate the connection between water and bare rock. And the light summer and winter drizzles that the area receives, and they are called guti in local terminology, are actually an experience or a process where granites are actually fed by such precipitations. This slide attempts a general geomorphological characterization of granite landforms based on what is generally observed on the surface and subsurface. This is very standard. The terms given for each feature and landform is usually local or regional in terms of context, with some of these terms acquiring universal acceptance. So you get terms such as Douala, such as Inselberg, such as Welbeck, then terms such as Castle Coppice, and terms such as H-plains, Nubins, or regolith. All of these terms have actually been universalized in references to the kind of geological terms that we normally associate with granite landforms. Now, critically, weathering and erosion are key towards the formation of granite landscapes, as one can see around Great Zimbabwe. And the key outcomes are exposed rocks, whatever size, be it local or regional. Then the talus slopes, the plains, the regolith, and the bedrock. And this is all you find at Great Zimbabwe, from well-baked copies to castle copies to Nubians, as well as pin plains. This is also what we see at Great Zimbabwe, where every landform is known by a local name. I have made references to Maware or Ware, which are the well-baked copies. And then the small hills that we call Shikomo. The smaller hills, we call them Shikomonyana. And then the areas between all these are also understood locally in terms of the plains, the pin plains. They all possess or have been given local names, local understandings in terms of how we characterize the landscape in and around, a particular setting. And in this case, Great Zimbabwe. Now, although these landscapes appear to be separate and individual formations or structures, they're actually connected below the ground, where they form solid underground granite basins. And I will revisit the point later on in the presentation. So what you see on the ground at Great Zimbabwe and beyond are actually pin plains or H plains, which is really a process of H-planation as already described in most scientific literature. From the geomorphology, let us turn to the geological context of Great Zimbabwe and the Southern African region. And here we are dealing with crystalline basement rocks, which are the hard, igneous or metamorphic rocks such as granites, basalts, and gneiss. These are the dominant rocks on the Zimbabwe Plateau, as well as the Southern African high veld, what we call the Kapval craton. The rocks are formed several kilometers beneath the surface and appear, of course, on the surface as exposed outcrops. Here on this slide, I show the map of Southern Africa, illustrating the distribution of crystalline rocks. And the location of Great Zimbabwe is shown here by the red dot. Now, the profile and weathering characteristics of these basement rocks is very well known in scientific literature. Unconsolidated material overlies decomposing bedrock, and profile fracture density decreases with depth, and so does porosity of the withered rock. This has implications on water storage in such contexts. Here is a diagrammatic representation of typical crystalline profiles, showing the nature of rock decomposition as one approaches the surface. It means from the bottom as one goes, to the surface. What about that? Now, from the bottom, there is what we call bedrock, with no visible signs of withering, which is followed by regolith, which is first slightly to moderately withered, and then highly or completely withered rock. The latter is residual soil, which most of us interact with. Now, the clay minerals in each determine what we refer to as porosity and permeability, the point which I'm turning to right now. Now, to explain this further, and in relation to hydrological qualities of the rocks, the following points are very important. First, that fracture density decreases with depth, and so does porosity. And secondly, the overburden is high porosity and medium to low density permeability. And this is due to clay-rich inclusions that you find in the regolith. Thirdly, the way that fractured rock aquifers are developed within the overburden. And fourthly, when saturated, the regolith becomes the reservoir of the aquifer. And fifthly, the regolith zone slowly feeds water downwards into the fractures that you find in the bedrock. Now, here is what we know about the water potential of crystalline rocks, and this knowledge is universal. The first point is that due to their medium to low permeability, their aquifers have modest water resources when compared to karst or volcanic landscapes. Secondly, in order to make good aquifers, their subsurface horizons, or the subsurface horizons of crystalline rocks, must be highly fractured. Thirdly, some crystalline rocks have exceptionally high water flows, which significantly contribute towards the supply of drinking water to fairly large settlements. And here I'm also including cities. Now, to extend that point, in economically and physically water-scarce semi-arid or arid regions of Africa, groundwater from crystalline convex is very critical. Such water convex have to be accessed. And recent research around boreholes have indicated that access is actually easy. They are either not very deep or they are inexpensive to extract. The harvesting of water through exit points from aquifers is important. For many communities in the rural areas, the digging of wells to access such water is very important. It's very critical. And using this information, let me take you back to Great Zimbabwe and attempt to highlight what happened when it was still in existence. And here, LiDAR scanning has proved critical in this regard. Firstly, LiDAR reveals the presence of several closed depressions that are highlighted in blue on this particular slide. The biggest depressions being found around this hill here, and in between these two lines, which are actually perimeter walls. Secondly, LiDAR shows the water stream channel network. Again, you can see the stream channel network with streams flowing in all directions of Great Zimbabwe. From Great Zimbabwe. Right, these are the streams. Now, critically, these streams flow from granite hills and pass through the pits. In other words, they feed into the pits and then they take some of the water out of the pits and away from Great Zimbabwe. Thirdly, a majority of these streams, and this is a very important point, are actually subsurface. And what you see here on this slider is actually being revealed through the scans that we did. So the pits that I'm referring to lie in positions that maximize the collection of surface runoff and retain water in the vicinity of the ancient settlement. So this is what is actually happening at Great Zimbabwe as we speak. We also consider some of these observations we made from the soil sampling, which also speak to the hydrological characteristic of the granite context. So the first point that we see happening at Great Zimbabwe is that it lies on a granite outcrop and is actually it's part of an extensive edge plane. So there's both the granite hills, the rocks, and then around those rocks and formations are the edge planes. It is from these that determine the runoff from the hills, where it should go, and where it is actually harvested. The second point is that Great Zimbabwe lies on an aquifer. Because of what I've given you in terms of the composition of the granite around Great Zimbabwe, from what you see on the surface and what you see in the subsurface, what it means is that Great Zimbabwe is actually built on top of an aquifer. Well, we do not know as yet the size of such an aquifer, but what we know is that there are some springs around the Great Zimbabwe territory that have a high discharge rate. In other words, they yield a lot of water, while others have modest or low rates. Some that are known in local narratives, they've actually dried up. So this tells you about the variation in terms of water supply in the past. Now, from our soil profile analysis, we have actually discovered that we have deep reddish orange coarse-grained to medium sandy clay loam soils, which actually originate from the withering of granite and basalt material. These are actually aquiferous in nature, yielding or containing and conveying groundwater. Now, the other soil profiles that we recorded at Great Zimbabwe comprise dark brown fine sand silt loams, which soils are actually, or which profiles are actually around the complex, the architectural complex. And by extension, these suggest that what you are seeing are actually anthropogenic, indications of Great Zimbabwe. In other words, human presence on the landscape. Given these observations, here is what the ancients did, because although LiDAR does tell us a lot in terms of what we see and we now know because we've information that is coming from the subsurface, it is important also to acknowledge that the LiDAR does not tell the whole story. What we can say is that the residents actually tapped the water from the watershed, from the withered bedrock, deep down some of these pits. And it appears Great Zimbabwe residents identified fractured zones that yielded water. Now, this slide, the top, right slide, shows you the depth of such pits and how far down to almost the bedrock they went, which means that if the water levels were variable, it would mean that, the residents had to do something to ensure that they were also able to access water that deep. So it appears Great Zimbabwe residents identified fractured zones that yielded water, and this must have required the use of, according to our oral histories, oral narratives, traditional mapping techniques, in other words, the dowsing, and other surface observations that we did, for example, what is called geophysical auscultation. These are some of the methods that people use traditionally to try and map water resources. In reaching towards closing, I want to reflect a couple of points based in this context. That water crises are ranked as the greatest global risk to economies, to environments, and societies in the current as well as the next decade, posing great threats that climate change is already part of, and a risk that is even greater than climate change. And some of this information has been discussed, at the World Economic Forum and other forums as well. It's also important to note that the world is already experiencing increased water stress in the form of reduced river flows, spring or reservoir depletion, threats to settlement growth, etc. And what we must realize is that water is more than just a climate issue. Water triggers conflicts, water affects mobilities, and impacts on ecosystems. It also affects economies and so many other things. Now, this slide poses a number of questions that we may need to reflect on, which have a bearing both in terms of the past and in the present. The first question is being that what insights may be gained from a better understanding, around, human responding to contemporary climate change or crisis. Secondly, how should we use the past to understand the current water problems that we're experiencing globally, be it in terms of water scarcity, droughts and extended dry periods, or even flooding? And secondly, and this is a direct bearing on Great Zimbabwe, how should we understand decline or collapse of ancient societies, however theoretically framed in terms of how we should be thinking about the meaning of decline or the meaning of collapse of any society. But in this particular case, collapse of state societies, collapse of kingdoms and empires. What I can only say in closing is that Great Zimbabwe's water needs must have risen with the growth of the ancient city, and that water was central to its economy, political stability, and the ecosystem. Contemporary global research on hydrological characteristics of crystalline rocks seem to have been already known more than 500 years ago and beyond. And this is some of the knowledge that the Great Zimbabwe ancients actually used to try and harvest water from around their environment and to ensure that the settlement system, which grew into an urban complex, survived as long as it did. Now, this allows us to understand what may have happened to Great Zimbabwe in the 16th and the 17th century, which is part of ongoing research and which I hope to be presenting, as part of the Munro lecture in Edinburgh next year. So thank you once again for the opportunity. I'm available to answer questions you may want to raise in connection with this lecture. And let me also acknowledge some of the people that were critical to some of these ideas emanating and being developed up to this point, particularly, Dr. Frederica Sulas, now at Gothenburg, who invited me to a center of excellence at the University of Aarhus, that is EBNET, where I was visiting professor in 2019 and where I developed some of these ideas. The National Research Foundation of South Africa for the funds, as well as the African Humanities Program, which funded grants for fieldwork and travel. Thank you so much.
Thank you very much for that absolutely fascinating lecture. I've got a lot of questions myself, but I'd like to throw the floor open as well to anyone who would like to either. I'm not quite sure how the technology will work here. Can people ask questions directly or should they put them in the chat?
Well, they can work. It can work both ways.
Well, you have the option of either putting your hand up or putting a question in the chat, and we'll take them. We'll take them either way. I wonder if I might ask the first question with the chair's perhaps abuse of privilege. I'm very interested in the suggestion that, well, not the suggestion, the clear evidence that this was all very well understood a long time ago. Do you think when people first began to settle and develop that site, they were aware of all its potential and how the system worked? Or do you think that that knowledge was built up over time through experience of living there?
Yes, Amanda, good seeing you again virtually. I think when one looks at the entire Zimbabwe plateau and where most of these monuments are found today, that more or less coincides with this distribution of this crystalline condex, it would appear this knowledge was built over time as a way of trying to cope with the challenges of limited water. And here we're talking about a plateau where most of the rivers on the Zimbabwe plateau are actually sourcing their water from. So it means that there had to be ways of managing running water to retain a critical mass of the water that would sustain a society for a year or so. That would be my answer for now.
Go ahead, Ranjit.
Yeah, good evening, everybody. Good evening, Professor Pikirayi. Thank you for this wonderful lecture. I, of course, am trained in history and not at all in archaeology and least of all geoarchaeology. So I speak from a position of complete ignorance. I just wanted to know that since water was such a and has been such a scarce and a valuable resource, does the evidence from the landscape indicate any attempt to control its use, any kind of a stratification amongst the communities which were using these resources?
Yes, Professor Duta, thanks very much for that question. I think water control is always critical, but the evidence is not always documented. To begin with, I also trained initially as a historian, at least up to the master's level. And then I decided to branch off into both history and archaeology. So I'm able to draw from the history and the archaeology, and also try to specialize within the the other disciplines that inform the archaeology, this time the geomorphology and the geology. So I'm trying to multitask to understand what I call deep history, and how it informs the present. Now, with regards to water control, what I know is that communally, when you talk to local communities, they tell you about clans who control certain springs, and around these springs they do conduct rituals and ceremonies just to ensure that they got the blessings of the ancestors, and that such rituals are also done in such a way that the belief is like, if you maintain ritual or ceremonial purity, these sources would not dry up, because drying up is a catastrophe. So there is an element of control. There is some sort of hierarchy in terms of who does that, but it starts with the local level. It becomes serious at a higher level when chiefs and kings try to interfere with what happens locally. But the examples around that are far and in between.
Thank you. Thank you so much. Yeah.
Professor, while you were speaking, I was reminded of a 100-year-old observation by Benedetto Croce. All history is contemporary history, he said. And I don't know much about the history, and particularly the archaeology that you are speaking of. But I was struck by the illustration that you have given, as it were, of the observation of Benedetto Croce. All history is contemporary history. So I was constantly struck by the fact that, and you made the point towards the end, that what was known 500 years ago is so relevant today. What we are studying in terms of old history is so relevant today to today's problems. So it's just a comment. There is no question here, but I was fascinated by the relevance of what you discussed to the observation made by Croce 100 years ago. Thank you anyway.
Yeah, but thanks for that observation, Professor Mukia. I think what happened here was something curiosity driven in terms of trying to understand the soil profiles, and in the process we ended up interacting with the granite, because it's also the granite that leads to these profiles anyway, through the withering. And then in interrogating what was happening and generating the water that we saw during the process, we then went on to dig the literature in terms of what is happening in granite or crystalline context broadly. And that's where I found a lot of literature from Europe into the sub-Saharan African region, as well as the Indian subcontinent, that this is the research that many have actually been conducting, in terms of hydrological studies over the last, 20 to 25 years. Yeah. And then I said, what is the imperative here? The imperative really was about trying to understand yield capacity in crystalline context, and when compared to karst landscapes, where, and I've been to Florida in the last few months, if you visit a spring in Florida, you get millions of liters, but you don't get the similar thing in granite context or crystalline context broadly. So it's really a relative way of society trying to cope with, such kinds of environment. So that's when we came up with this kind of information to say, I think this knowledge was well known before we started engaging with it, is in the manner that we're doing right now.
Indeed, yes.
Yeah.
Do you think that the ritual practices that you describe have been a part of that interaction all along, or in some form or another?
Yes, I think the only challenge is that we do not know how far back, given the problem that lies in dating the oral traditions. But we know, at least as far as this area is concerned, from the 17th, 18th century, some of these springs, seems to have been owned by clans, and the clans really safeguarded them. One of the springs was actually located almost at the center of Great Zimbabwe, and is connected with the ritual around a girl or some a similar person, and it is one of the reasons why that particular clan would claim that they are actually the real owners of Great Zimbabwe, not other clans. So it's part of the contestation of the site through avenues such as water that you get these kinds of developments. So there is some history to it, but how deep into the past is still very difficult to tell. We'll still investigate and see what we can get out of it. It's something that is curiosity driven as well.
Yeah. Please go ahead.
I'm not a student of archaeology, but usually granites are found in dry zones. Whether water bodies have any role in your presentation in the formation of granites?
Yes, I'm not so sure whether I understood your question, but the issue about granites is that although they look very hard and dry on the surface, they are made in such a way that when you look at the surface and the way they control water towards the soil adjacent to them, this water is actually channeled into the subsurface depressions that I referred to in the slides. And this is where you get the reservoirs that I'm talking about. And this is that proves to be a very critical catchment, because in those areas, the porosity is almost zero. So that's where the yield is actually determined from.
Just coming back to, oh, I'm sorry, go ahead.
No. I'm actually, it's just, just an idea, just a comment, because, where archaeology in South Asia is concerned, water resources and environment and sustainability is being explored. And your granite rocks remind us of the Deccan region, which is a plateau region, where you have similar water reserves, which were actually guarded by the pastoral communities. And they acquired a status of sacrality. And today, some of these sites are very important pilgrimage centers. So is there, I was just wondering, pardon my ignorance, so is there any continuity of the past tradition as a living tradition today in this particular region?
Yes, indeed. In fact, it's very interesting to learn some of those experiences in India. In fact, when I was reading literature from the Indian subcontinent, I was only focusing on the scientific bit or the scientific aspects without looking at, the historical and the ritualized, context, because, it's something that I thought was far much more complex beyond my reach. But with regards to Great Zimbabwe, the biggest punctuator or juncture was really colonization in the 1890s, where those who appropriated the site tried to stop all these traditions, tried to stop community access to the Great Zimbabwe landscape. In fact, some of these springs and their catchments were interfered with in terms of either cutting down the trees, filling them with cement, and when you do so, cement does actually desiccate the whole water, context, and then it dries up the spring. Or they would actually interfere, the hydrological context of much of the ash plain of Great Zimbabwe by way of planting eucalyptus trees. Now, these have got a long taproot and they take away all the water from the catchment. And so to rehabilitate those contexts, it requires a lot of time. It also requires communities to reaccess the same environments. So it's only post-1980 when Great Zimbabwe, when Zimbabwe became independent, that archaeologists and heritage managers are beginning to talk about community access in terms of management of the site and this broader landscape. It's beginning to happen now. Water is available, particularly beyond the core site, where some of it is actually being used for agricultural production, and quite successfully so.
Mm-hmm. Thank you. Thank you so much.
Yes.
One of the things that's very striking about climate change responses everywhere is the fact that people in many cultures have forgotten, or for a long time haven't had very sensible ways of thinking about their resources or their environments, and it seems like one of the ways to maybe make necessary changes stick a bit better is to involve communities and to try and it's harder in some places than others. I mean, in the UK it's almost impossible, but how could people return to maybe a more ritualized or maybe a more intimate relationship with particular local environments? But it sounds as if there's a memory of that, at least, that's being built on in this context.
I agree with you, Amanda. I think, for Great Zimbabwe, the biggest challenge is to try and swallow the pride where past literature has tried to deny environmental degradation as a potential cause for the demise of Great Zimbabwe. I'm trying to revisit that together with my colleagues. Then the other broader sort of reality is that as long as we deny climate change, and as long as we deny local communities and indigenous people of the understandings, in plural, about how to deal with the problem, then we are stuck in terms of trying to find out what it is, trying to understand what it is, and also trying to proffer a solution in terms of, what do we do to stem global warming, and what do we do to sustain communities, that lived in harmony with these environments for such a long time.
So as you mentioned that in your lecture in Edinburgh next year, you're going to be talking about what might have made Great Zimbabwe collapse.
Oh, yes, I'm going to try that, and that is a promise for sure. It's something that is in the making, because one cannot conjure up a suggestion. One has to build up an argument, over a sustained period, and as long as evidence is coming and is suggesting that this could have brought an end to the site, I'll gladly take that on board. In fact, part of what I did discuss in the keynote I gave, I think at Leeds, or with Leeds, during one of these conferences, the International Medieval Congress, was to talk about the medieval, what was it? These medieval climate episodes where we talk about the Little Ice Age and the medieval warm epoch. These categories we don't use in Africa in general, but I tried to invoke them to see exactly whether at least we can have some time, frames in which we can also try to understand, not really in terms of framing African history, but understand what happened, to certain key civilizations that could have been impacted on by, water shortages or a sudden change in the global climate. Because if it is global climate, then something should have given in to some of these complex societies. So that's the thing that I'm coming in with in Edinburgh next year.
It sounds like a really interesting contribution to this discussion. I've read a bit, not as an expert at all, about Cahokia on the Mississippi and also the Angkor communities, and both of them, it looks like, maybe using similar methods to yours, were affected at least by change in waterfall, in rainfall quantities, even if the temperature profile isn't the same as in the areas where the climate anomaly is to do with temperature as well.
Yeah, the bottom line is we still do not know what may have happened to Great Zimbabwe without enough data sets that we should have built in a couple of years back. We are still, or we've been up to this particular point on the very speculative phase. But I think we are slowly beginning to cross that phase into something more definitive. And we should be doing so because when we talk about the past, people want to see how the past links to the present. When they say what happened to Great Zimbabwe, they're asking that question in the present because they are trying to say, can we avoid that thing happening to us, right? So these are relevant questions we should be asking. And these are issues that also makes archaeology and deep history relevant, because we cannot just leave the past in the context of the past, but the past always replicates itself in the present. So this is the manner in which I'm approaching Great Zimbabwe.
So I completely agree with you. I think it's absolutely crucial. And I mean, also as a wider point about the discipline of well, medieval history or whatever we want to call it, there's just a risk in agreeing that we're not relevant rather than making arguments for why we are, just in terms of funding and things. But I think quite aside from doing that strategically, it's really essential for understanding these very long patterns of resilience and collapse. And I suppose just adaptability. That's what seems so interesting. Adaptability and particular kinds of knowledge that communities build up over very long periods of time, and then maybe lose with modernization. And yet perhaps it was the better way to understand things all along, or maybe the more environmentally alert, more sensitive way to understand things.
Yes.
I was wondering if anyone else had any questions. I've asked quite a few. In that case, I wonder whether we should wrap up the session. Would that be agreeable, Professor Mukia?
Please go ahead, Amanda. Wind it up. Yes.
Well, I think in that case, it remains to thank you very much for that paper, which I found extremely interesting and very thought-provoking for maybe kind of wider applications as well of the sort of work that you're doing. So we're very grateful for you coming and giving the lecture, or recording the lecture and coming and speaking to us. It's extremely interesting and much appreciated.
Yeah. Let me take this opportunity to really thank Professor Mukia and all his team, yourself, for being available and for encouraging me to to speak about these ideas for the first time using this platform. I really appreciate this kind of engagement, and I can assure you, you will be seeing a publication on this, as well as another follow-up paper, following the Munro lecture next year. That's definitely coming. It's a promise that I will fulfill. So thank you to all, and for those who have attended from the subcontinent. I really appreciate your time and your commitment to this. So go well.
Thank you.
Thank you very much, everyone.
Okay, bye-bye.
Bye-bye.
Well, there are two more Thanksgiving to go, one by Ranjita and the other by Debbie. So just hold on for 5 minutes, 7 minutes. Yes. Please, Ranjita.
Okay. Hello, everybody. On behalf of the Medieval History Journal, I'm thankful to Professor Pikirayi for delivering an excellent lecture as a part of the annual lecture series on the water resources and environment and landscape in the ancient city of Great Zimbabwe. Medieval History Journal focuses on themes of spatial transitions, and engages with a comparative transcultural scholarly conversations. In this context, today's lecture definitely addressed and engaged with very important questions of methods, of chronology, as well as environment, landscape, communities, and the knowledge system. We are happy and honored that Professor Pikirayi, despite his busy schedule, accepted our invitation and cooperated with us totally in making this lecture a big success. The editorial collective of MHJ has extended valuable support for organizing this lecture. A special thanks to Amanda Powers for making this happen, and also chairing the session today in between a busy academic schedule. A special thanks also to the other members of the collective, uh, Sally Church, Suraya Faruqi, and Lester Ratnath, who's here, Prasannan Parthasarthi, Walter Pole, Samira Sheikh, Kim Sieben-Huner, who was also here a short while ago, and of course, Professor Harbans Mukhia, the founder editor of the journal. We worked as a team, and it was very nice that we stood in support of each other. On behalf of the collective, I thank SAGE for supporting the MHJ lecture series. We are in the 15th year, and this would not have been possible if SAGE had not been forthcoming with their logistical support to the journal. And there are one is extremely grateful to Neetu, to Smriti Sudhakaran, Archana Jha, Debbie Dhar, Harshita Kalra, Neha Bahuguna, and Sangeeta Gupta for all the possible support and answering our small queries. A big thanks to all of you who took time to across different time zones to attend the lecture on the Zoom platform, on Facebook, and on YouTube, where it is being streamed. It was really enriching to interact with all of you and see all of you there. And with this, I conclude my vote of thanks. So thank you, everybody.
Let me just announce that the lecture text of the lecture will be published in the May 2024 issue of MHJ, and that the lecture would be available on YouTube for pretty long time. Yes, Amanda, please go ahead.
Sorry, I realize I'm muted. I have to say goodbye to go and get organized for some teaching, but thank you very much. I'm really glad to have heard that lecture. And
thanks a lot.
Thank you. Bye.
Thanks a lot. Bye. Bye.
Yeah, sorry, I believe my video was working till earlier, but somehow when I switch it on, it's only showing the Zoom background. Sorry for that. If I switch it on, you won't be able to see me. But it was just a quick vote of thanks where we wanted to thank everybody. I believe Professor Pikirayi has already left, but we wanted to appreciate his lecture, and we wanted to appreciate the entire team. Thank you, Professor Mukhia, Professor Ranjita Datta, and Professor Pratyanath, the entire editorial collective as well. And just quick points we wanted to highlight about the journal is that this journal has recently got its impact factor 0.5. It's indexed in Clarivate Analytics AHCI anyway, and it's also has a ranking amongst the top 400 journals in history within Scopus. So it's continuing to grow, and it's got submissions from all across, from Asia, USA, Europe, and Middle East. So I would like to just highlight how the journal has been growing in leaps and bounds. So, and thank you everybody who has joined.
Great.
That's all from my